Alrighty, folks. So today we are going to go ahead and review for our exam for Unit B. So we're going to go through this Kahoot and talk about what the correct answers are and why they are the correct answers. So for this Kahoot, I will be playing as the Expert Seal. Very good. Alrighty, folks, let's go ahead and do this. All right, question number one. Electrons in the first energy level of an atom. So that is going to be whichever are in the lowest or the energy level closest to the nucleus, and they are going to have the lowest possible energy. So the closer you are to the nucleus, there's more of that attraction between the positive charge of the nucleus and the negative charge of the electron, and so they are going to have the lowest possible energy level. As you move further out, you are going to require more energy to get farther away from that positively charged nucleus, and so higher energy levels have more energy. All right, next up. The electron configuration with the lowest possible energy is known as, that is going to be the ground state. So whenever an electron is as close to the nucleus as it can, the valence electrons, that is going to be their ground state. And then you can see here energy comes in and it bumps that electron up to a higher energy level, which is called the excited state. Next question. How many electrons does aluminum have? So right here we have aluminum's periodic square, and we're going to look at the atomic number, which is this number 13, and that tells us the number of protons, and the number of protons is equal to the number of electrons, so the answer is 13. Question 4. How many neutrons does aluminum have? All right, so this one's a little bit trickier to figure out. We start off by looking at the average atomic mass here, which is the average mass of all the isotopes. The most common isotope will be this number rounded, so we get to 27. That is the number of protons plus neutrons, so we subtract the number of protons, 13, and that gives us 14 neutrons. So mass number, 27, or is this number rounded? 27, and that is the number of protons and neutrons. You subtract the atomic number, which is 13, the number of protons, and that leaves you with just the number of neutrons, 14. Next question. What is the mass number of aluminum? Well, we actually just kind of talked about that. You take the average atomic mass here and you round it, and so that is going to be 26.98 rounded to 27. All right, next one. What is an isotope? So, kind of a vocab term, but isotopes refer to neutrons, and so that is going to be an atom of the same element with different numbers of neutrons. If an atom has a different number of protons, that would just be a completely different atom. Any sort of neutral atom is going to have an equal number of protons and electrons, and an atom with of the same element with different numbers of electrons is called an ion. Next question. Which subatomic particle is positive? Well, our positive subatomic particle is going to be our proton. All right, next up. What is the mass number of boron? All right, for this one, I've given you a Bohr model of boron, and remember that the mass number is going to be the number of protons plus neutrons, and so it's going to be 5 plus 6, which is 11. All right, which isotope of boron is this? All right, so remember that the isotope nomenclature is going to be the name of the atom or the element followed by its mass number. So we already figured out that the mass number is 11, so it'd be boron 11 is this isotope. All right, next up. How is the modern periodic table arranged? Well, the modern periodic table is going to go from 1 to 118, and that 1 to 118 is the number of protons or the increasing atomic number. What is not true of the group of elements shown? All right, so we are highlighting this group right here on the far right-hand side. And so they do not have any valence electrons, so they are we're just going to, or not true. So because they don't have any valence electrons, they are noble gases. They are not very reactive. They are actually inert. And so noble gases all have a full outer shell of electrons. Most of them have 8 valence electrons, except for helium, which has 2 because it only has 1 electron energy level, which is filled by 2, and they are called noble gases. Next question. What elements are located along the stair-step line? And we have that highlighted right here, these green elements, and those are called the metalloids. They have kind of properties of both metals and nonmetals. Next question. Metals have all of the properties listed except what? Well, metals are shiny. They are malleable, meaning they can be bent. And they are good conductors of heat and electricity. However, metals are not brittle. Brittle means that if you have a metal or you have something and you try to bend it, it snaps. And metals will bend but not break. What is the general trend in reactivity of metals as you move down a group? So let's look at our metalloid or our alkali metals and go from lithium down to cesium. And the answer is that as you move down, each one is going to get more and more reactive. So they are more reactive at the bottom. We watched a video about this where they put lithium into a bathtub or into some water and kind of skittered around. And by the time you get down to potassium and cesium, things like that, it causes quite the explosion when you put it into water because it is so much more reactive. The number of valence electrons increases as you move. Well, as you move from left to right on the periodic table, you're going to go across the groups that increase the number of valence electrons, and so it is going to increase as you move across a period from left to right. Elements in the same period have what in common? So remember, periods go from left to right, and that is going to be the same number of energy levels. Chemical properties is going to be groups. Number of valence electrons is also going to be groups, and density has nothing to do with this. How many valence electrons does nitrogen have? So nitrogen is right here, and let's go ahead and figure it out. This first group right here has 1 valence electron. The second group has 2. We skip the transition metals. Third group 3, fourth group 4. Nitrogen's in that 5th group, and so it has 5. Next question. The most reactive non-metal on the periodic table. So non-metals actually increase in reactivity as you go up and to the right, not including the noble gases. And so that means that fluorine right here is going to be the most reactive non-metal. What is the purple group called? Well, this group right here, this group is the purple one, and that is going to be our halogens. The red group is the alkali metals. This white group in the middle here is the transition metals, and the light blue group is the noble gases. All right, last question here, folks. How many valence electrons does the light green halogen group have? So we've got a slightly different periodic table here. Halogens are highlighted in light green, and actually we've got a nice little piece of information right here. You see that 7A. Remember that when you see that, the number next to the A is the number of valence electrons, so it has 7. Alrighty, folks. So that's it. That's the Kahoot. Hopefully that was helpful. And as always, if you have any questions, please feel free to reach out to your teacher.